Okay, amines. Now, amines are derived from ammonia. So you're not to get too confused when you think about amines, you just need to think about ammonia. So let's start. We take ammonia, let's do a bit of revision first. We take ammonia, what shape, what bond angle does ammonia have? Okay, so ammonia has 3 bond pairs, 1 lone pair, so it has a pyramidal shape, and it has a bond angle of 107 degrees. Okay, so if amines are derived from ammonia, all you need to do is take your ammonia, and what we're going to do is we're going to replace one of the hydrogens with an R group. When we say R group, we mean an alkyl group. Okay, and then the 2 hydrogens are still there. So for example, if we take, so it'll be RNH2. So if R was methyl, for example, like that. Okay, and so that is called methylamine. That's called methylamine. But the bond angle is still going to be the same. It's going to be 3 bond pairs, 1 lone pair, pyramidal, 107 degrees. Okay, that's called a primary amine. So I'm just going to abbreviate it like that. A primary amine. So just think very simple, just think like ammonia. Now if we do that again, if we take the ammonia, and we've got 1 R group, and we substitute the hydrogen with another R group, doesn't have to be the same, can be different. Okay, so you've got 2 R groups, so if we have them the same, now what you've got to be careful of now, because nitrogen can only have 3 bonds, so you've got to be careful because you've only got 1 hydrogen. So just be careful of that. You've got 2 hydrogens, now you've only got 1 hydrogen. So if they are the same R group, so if it was 2 methyls, okay, then that would be called dimethyl amine. Okay, and that is classified as a secondary amine. Because you have got 2 methyl groups, 2 R groups, a secondary amine. So primary amine has got 1 R group, a secondary amine has got 2. Okay, you can have different though. So say if we had, let's say for example, we had, let's say we have methyl, yeah? But what if we have an ethyl on there as well? And then we have a hydrogen. Okay, so what if the 2 groups are different? The way that you name it is you take the longest carbon chain, so that would be called ethyl amine. Ethylamine, because it's the longest carbon chain. And then there is a methyl group, but it's on the N, so you would call it N, capital N, N-methyl ethylamine. Okay, so that's how you'd name it. So the N-methyl, and then the longest chain, ethylamine. Right, so the last one, if you can have primary, you can have secondary. Can you see that we can just do it again? Then we have the R group, and we can have another R group. So we can have 3 R groups. But now the nitrogen does not have any hydrogens. Okay, so for example, if they were all the same, if they were all methyl, that would be called trimethylamine. And it would be a tertiary amine. Sorry, Reggie's not very good. Tertiary amine. Okay, So let's go have a go at naming. So say if we take, right, so let's take a tertiary amine. What if we have a methyl group? What if we have an ethyl group? And also we have a propyl group. Okay, that is a tertiary amine. So how would we name it? So you take the longest carbon chain, so it would be called propyl amine, which is the longest carbon chain. Then you put them in alphabetical order. So that would be, that's ethyl and that's methyl, right? So it'd be called N-ethyl dash N-methyl propylamine. So it's alphabetical order, EM. Okay, and that's how you'd name that. And it's a tertiary amine. Okay, finally, before we move on from naming, another thing as well with naming is if you take something like this, if you take, say maybe you've got 4 carbons like that, okay, and with all the hydrogens, okay, so that's called, 4 carbons would be called butyl amine, okay, but you only use this when it's on carbon 1. For example, if you have this, can you see that it's on carbon 2? Well, it's not called amine anymore. So what you do, the main chain is butane. And on carbon 2, we've got 2, it's called amino. 2-aminobutane. Okay, so that's the name you can use if it's not on carbon 1. So not on carbon 1. The amine group is not on carbon 1. Okay, right, 2-aminobutane. Right, and then let's do some reactions of amines. So it's just like bases, just like ammonia, yeah? So ammonia, just like ammonia, amines are bases. And this is all because of the lone pair of electrons on the nitrogen. The lone pair of electrons on the nitrogen can accept a H plus from an acid. Okay, so just like ammonia. So let's take ammonia first, a stupid of revision. Okay, so if you've got ammonia, okay, and you react it with an acid, what do you get? So you get the ammonium ion. So that's ammonia. So this is AS revision, and you get the ammonium ion. Let's look at it in terms of dot and cross diagrams. Right, if you've got ammonia, dot cross hydrogen, dot cross hydrogen, dot cross hydrogen, and a lone pair of electrons. Along comes a H plus. How many electrons does a H plus have? It doesn't have any electrons. It's just an empty orbital. And it forms a bond. Do you remember what kind of bond this is? It forms a dative covalent bond. A dative covalent bond. That bond there, dot dot, or cross cross, is a dative covalent bond. Okay, and then you've got your ammonium ion. Right, so that's what's actually happening. And just to be revision, remember we already said this is pyramidal, 3 bond pairs, 1 lone pair, 107 degrees. Electron pairs repel as far apart as possible, and lone pairs repel more. This is now 4 bond pairs, so this is tetrahedral shape. bond angle 109.5. Okay, so that's ammonia. Now amines are very, very similar. Very, very similar. If you take, let's just keep it simple. Let's just take methylamine. Methylamine has a lone pair of electrons. Methylamine can accept a H+, and it forms, just like here, it forms methyl ammonium ion. So instead of the ammonium ion, it's methyl ammonium. Oops, I'm sorry. Methyl ammonium ion. Methyl ammonium ion. Okay. So if we actually did this properly, if we took methylamine and we say we took hydrochloric acid, so not just H+, then you would get the salt. What would the salt be called? It would be called methyl ammonium chloride. Methyl ammonium chloride. Okay, let's make it, that's a salt. It's a salt. Let's make it slightly more complicated. Okay, slightly more complicated. Let's take ethylamine. Ethylamine and phosphoric acid. Phosphoric acid. Okay, just write the name underneath. Phosphoric acid. Phosphoric acid, that's a C. Okay, so straight away you can see you've got 3 H+. 3 H+. So you're going to need 3 of the amines. And you're going to get the amine. It's going to accept a proton. But it's going to happen 3 times. And then the PO4 3-, and that would be called ethyl ammonium phosphate. I'll squeeze the name on. Ethyl ammonium phosphate. Maybe used as fertilizers. Ammonium salts can be used as fertilizers, for example. Okay, so they're just like amines, right? The last thing is for this section is how to make an amine. You have to synthesize an amine. How do you make an amine? Right, so if you, let's start with, we've been very, make an amine. How do you make an amine? How do you make an amine? Okay, the pen needs to run out a little bit. Now, if you take, let's just take this. I'm going to draw this out like that. Okay, so that's chloroethane. Chloroethane, right? So we know already that it's a polar bond, yeah? So you got a polar bond, there like that, okay? And if you add ammonia, and ammonia's got a lone pair of electrons, ammonia can come in and attack the carbon and break that bond, yeah? And make the amine. And then it'll be NH2. It's going to make a bond between the nitrogen and the carbon, and then the other atom is HCl. Okay, so this is called nucleophilic. Remember, there's only one L there. Nucleophilic substitution. Okay. Now that equation that I've written there is not actually completely correct. Yeah, so because what actually will happen is if you take chloroethane and ammonia, if we're being very proper about it, we should make the salt CH2 NH3 plus Cl minus, which is the salt, which is the ethyl ammonium chloride salt. Okay, but that just shows you what is actually happening to make ammonia, to make an amine. Okay, so then this is a salt, but there's a second step now because the salt you need to make the amine. Okay, quite a lot of amine molecules. I've got quite a fishy, kind of fishy smell. Okay, so ethyl ammonium chloride, what you do is you add sodium hydroxide and that releases the amine. So you have CH3, CH2, releases the amine, plus you're going to have sodium chloride, plus you're going to have water, aren't you? Water, okay? That's how you make an amine. There's certain conditions. You've got to make sure that you use ethanol as a solvent. No water, you don't want any water present, okay? Because if you have water present, then what potentially can happen if you have water present is that water can come in and attack as a nucleophile, and you'll get alcohol as your product. So you don't want any water present. Another thing as well, for this reaction to work, you need an excess of ammonia. And the reason why you use a lot of ammonia is to prevent further substitution. So for example, as soon as we make this product, can you see that this product has got a lone pair of electrons? The product can just as easily come in and attack, and then you get a secondary amine. So if the product was to come in and do this, then you would get the secondary amine, NH. And can you see if you get the secondary amine's got a lone pair of electrons. That can come in, keep going, that can come in and attack and substitute again and get further substitution, and you can end up with a tertiary amine. Like that, a tertiary amine. So it's really important that if you want to make the amine, you have excess ammonia and to prevent the further substitution that can happen. Okay, this is the only way to make this is an aliphatic amine. This is when you want to make an aliphatic amine, which means a straight chain or branched amine. To make an aromatic amine is a slightly different method. Last thing we're going to do, making an aromatic amine. So making an aromatic with a benzene ring, aromatic amine. Okay, aromatic amine. So if we want to make, for example, this here, which is called phenylamine. Can I just mention connectivity? Connectivity, you've got to make sure your bond is going to the nitrogen. Right, this is a different method. If you're making an aromatic amine, it is different to an aliphatic amine. You take nitrobenzene, it's called nitrobenzene, and it's a reduction reaction. It's reduction. So if it's reduction, you need, remember what we use when we do reduction? You need hydrogen in square brackets. The reducing agent is tin and concentrated HCl. You need both of those is the reducing agent. You'd also reflux it as well. And then you would also add excess sodium hydroxide in order to get rid of the salt and get the amine. Okay, so what do you think the other, we've got 2 oxygens here, so we're going to need 2 waters. And then we've got 4 hydrogens, 2 hydrogens, that's 6 hydrogens, so put 6 hydrogens here. And the sodium hydroxide is just to convert the phenyl ammonium chloride to the phenyl amine. Okay, and that's how you make an aromatic amine.